So let's start with our simple scenario. How many times did our customers type the word refund in emails sent to Indiana University? So when so without data, um, our Hadoop cluster is pointless, right? So the first thing that we need to do is we need to take our data and we need to split it into chunks. Now, by default, it's set to 3 chunks, and those chunk sizes is 64 megabytes. Um, why is it 64 megabytes? Well, if you have your block size to be smaller, then it doesn't really operate well on small data because the overhead with actually maintaining the splits is a lot difficult with a map task. So it could also affect your performance that way. So also this number, however many splits, 3, can be changed in your dfs.replication parameter in your hdfs.site file, which you'll see when you download the source. So in this case, we have our 3 blocks of data, which was split from our large file. So what the client does, it actually pings the name node and asks the name node whether or not, or asks the name node for a list of data nodes to actually store these blocks of data. So once the data node gets these blocks, it'll actually replicate it. So, and there are some cases where the data node needs to read from the HDFS, possibly to process this data. But in any case, sometimes the data is not local, so it needs to fetch the data. So it needs to ask the name node or where this data is. And so the name node may actually have to go across the network. But see, remember that I mentioned this thing called rack awareness. The rack awareness, instead of having the name node fetch it across the network, it'll check its rack to see whether or not the data is located there so it can retrieve it. And that will actually cut down on the network congestion. But also, I want to mention that the job tracker wants the data to be located where the data node is. But there may be a case where there are data that is not actually being computed with the number of maps. So you may have a map task that is overwhelmed with the number of the data, so it may have to actually search it on its rack. So there are 3 phases with the map, sort, and the reduce phases here. Here, I have my map task. So here, the goal is to process the data. So each data has each map has a block of data. And so I want to be able to process that. So what it does, it asks the name node, the job tracker will ask the name node for where the data is actually located on the map task. And so once I do that, I apply, so in this case, I want to count how many times fraud actually appears. So, and that's basically it. So here, so this was somewhat of an abstract view of the map task, but here, to kind of put things into a little bit more perspective, if I have key and my values, then I map to, depending on what your application is, to produce an intermediate key value pairs. So, but let's think about it of a more detailed view here. So here I have my inputs, which is just a Word document, and I have 3 mappers. And so I want to actually count the frequency of the word that appears in the document. So so here it actually enumerates a 1 for each word. So now let's talk about the reduce. So now I have my mappers producing all of these the enumerations of each of these. And then I have my reduce, which sums them up. And actually, I store that on the HDFS and so that the results can be viewable to the client. So I have my reduce step. I have, from my mapper, I have a set of key and value pairs. So the values are condensed based on the key. So here I group them and condense them. And I do the same thing in my detailed example. So here I have a set of values and I sort them. And so here you can see that the was counted ever how many times, and I reduce, and then I get the values back here. So also, so now that I have my job stored to the HDFS, I now want to be able to see what my results are. And so what the client would do, it would ping the name node for a list of data nodes that are in that are able to read. So it will give me a list. So I read each data node and store them. So in conclusion, we introduced MapReduce for large scale data. We give you an example of the HDFS, and we illustrated the concepts through the good old word count example. And also, I just want to say that this is just, or this presentation is just to whet your appetite for studying more detail about Hadoop.